Section 10.6, Circles and Arcs. A central angle is an angle whose vertex is in the center of the circle. Well, this is a review because we've actually already covered this. Arc is a portion of the circle, the outer piece of the circle, the edges. A semicircle is half a circle. A minor arc is an arc that is smaller than a semicircle, so less than 180 degrees. And usually when you name minor arcs, you do so with just two letters. So arc AB. A major arc, on the other hand, is an arc larger than a semicircle, so it has a degree measure greater than 180. And when they usually name major arcs, they do so with three letters. So the three letters indicate the direction in which your arc is going around the circle. Here we're looking to list some minor arcs, semicircles, and major arcs for this circle. So pause the video, fill out your list, and then compare it with what I come up with. So here we have minor arcs AC, CE, DE, and AD. Semicircles would be DAC or ACE. And remember, the lettering could be rearranged in terms of you could say CAD and ECA. And then major arcs containing point A, ADC, AEC, ACD, and AED. All right, let's try this again. This time, pause the video, answer the three questions, and compare your answers to mine. Key concept, arc measure. The measure of a minor arc is equal to the measure of its corresponding central angle. We already knew this from previous sections. The measure of the major arc is the measure of the related minor arc subtracted from 360. And then the measure of a semicircle is 180. And then here they have the arc addition postulate, which is a lot like segment addition, part plus part equals whole. So this is a concept we should be familiar with. What is the measure of each arc in circle O? Well, arc BC has a central angle that is 32 degrees, so BC is also 32 degrees. BD is the combination of BC and CD, so we would take 32 plus 58, which is going to give us 90 degrees. Arc ABC is essentially a semicircle, so that has a degree measure of 180. And then arc AB is a part of that semicircle, but not the entire thing. It's 180 minus the 32 degree arc here, so that leaves behind 148. Try these 4 problems on your own, pause the video, and when you're ready to see the answers, unpause it to check your work. So arc PR is 77, arc RS is 103, arc PRQ is 208, and arc PQR is 283. The circumference of a circle is pi times the diameter, or it can also be written as 2 pi r, or 2 pi times the radius. We've actually already done some work with circumference, so this shouldn't be a new concept for us. Find the circumference of each circle, give your answers in terms of pi. So remember, we can leave our answers in terms of pi, or we could technically multiply them out into decimals. It's more accurate to leave them in terms of pi, however. So in this case, the 20 here is the diameter. So to find our circumference, we're going to take pi times diameter, which in this case would be 20 pi. If you're choosing to, you can also put this in decimal form, which would be right around 62.8 meters. And so remember, circumference is like perimeter. It's the measurement around the outside of the circle. Question 2, they've given us a radius. So we're going to use our circumference equals 2 pi r this time, which in this case is going to be, well, 2 times 4.2 is 8.4. So we're looking at 8.4 pi. Or if we want to write this in decimal form, it's right around 26.376 meters, or in this case, units. So either answer works. A merry-go-round has seats that are 7 feet and 10 feet from the center of the ride. How much farther does a child seated from the outside of the loop travel than a child seated in the inside of the loop in the completion of one rotation? So let's see if we can't draw the merry-go-round. It's not perfect. Let's try that again. All right, so what they're saying is they've got from the center of the circle, one child is seated 7, the other child would be seated 10. So we've got two different radii here. And so ultimately, we're going to compare the circumferences in terms to determine how far around each child goes. So let's say we've got circumference for 2 pi times the radius, that's 10. And then we've got our other circumference of 2 pi times the radius, that is 7. Well, here we end up with 20 pi. Here we end up with 14 pi. And to figure out the difference, we're merely just going to subtract them. We're going to subtract these two values. And we get that the difference is 6 pi, or right around 18.84 feet. So that means the child on the outside actually travels 18, almost 19 more feet than the child on the inside loop. Now to something new. Arc length, the actual measure of an arc as a portion of the circumference. So here we're looking at taking the circumference and dividing it up based on the amount of the circle we're actually looking at. So we're going to use the arc's degree measure to determine how much of that 360 rotation we take out of the actual circumference itself. So the length of an arc of a circle is the product of the ratio where you take the measure of the arc divided by 360 multiplied by the circumference of the circle. So we're going to be using this formula here, where it's measure of arc over 360 times 2 pi r, or measure of arc over 360 times pi times diameter. All right, so let's take a look at this. So first example here, what is the length of the arc in red? Well, for us, this happens to be in black and white, so I'll go ahead and indicate where the red's supposed to be. It's this section here. So we know that this would be 90 based on the right angle inside. So we're looking for the arc length here. Well, the formula calls for arc measure, so 90 over 360 times our circumference, so pi times diameter, because we have 16 as the diameter. Well, 90 over 360 is 1/4, so we've got 1/4 times 16 pi. So 1/4 of 16 is just 4. So your arc length here is 4 pi. In this case, you can put inches. And then again, if you wanted to, you could put this in decimal form, but like I said, the pi form is more accurate. All right, same idea here. We're looking for the length of this arc here. If the back half of this arc is 240, we know that this arc is 120. So we're going to take 120 over 360 times, in this case we have a radius, so we've got 2 pi times the radius, which is 15. Well, we'll simplify this down. 120 over 360 is 1/3, times in this case 30 pi. 1/3 of 30 pi is just 10 pi, in this case centimeters. What is the length of a semicircle with a radius of 1.3? Give our answers in terms of pi. So a semicircle has an arc measure of 180. So we're looking at 180 over 360 times, and its radius, so it's 2 pi times 1.3. So we can simplify this down pretty easily. 180 over 360 is 1/2, times, in this case, 2.6 pi. Half of 2.6 would be 1.3 pi meters in this case.